All right, everybody. Today we're going to talk about subtraction division, staying in 1.3. So first thing we're going to talk about is just some different operations on fractions. Hopefully you guys have seen all these before. I know you have because I've gone through most of them with you at one point in time or another. So shouldn't be anything too earth-shattering. I'm just going to show you how to do some stuff in a little different way today. So the first thing is cancellation property, or an operation here. So if you have AC over BC, C shows up in both of those, so you can cancel that C out of there, and you're just left with A over B. The big thing here is you need to cancel factors. Meaning, if I have x over x plus 1, okay, a lot of you try really, really hard to cancel those two x's, okay? That can't happen because we don't have factors. So if I were to have, say, x plus 1 all over x plus 1 times x minus 2, okay, now that this is all factored out, now my x plus 1 can cancel with this other x plus 1. That's fine, okay? But you've got to be able to have that be multiplied into there. So you need to cancel factors, not just terms. Addition, you guys hopefully all know that you need a common denominator, and then the denominator will stay the same, and you will be left with the two things up top being added together. So again, that's just how fractions work. If you don't have that common denominator, you will need to find one. Multiplying fractions don't need common denominators here. All you do, multiply across the top, so A times C, and multiply across the bottom, B times D, whatever that happens to be. With division, hopefully you guys have heard me talk about keep, change, flip, but all you end up doing is keep the first fraction the same, and you will multiply by the reciprocal, or flip the other fraction. So you keep the first one, you change division to multiplication, and you flip the second fraction, so it's going to be D over C. And of course, then you would just multiply just like you did in that multiplication operation that we just talked about. So that's really all there is to dividing fractions. When you multiply that out, or when you multiply your division there, obviously you get AD over BC. One other thing, and I just want to make sure you guys have it. We talked about it last year in Algebra 2, second semester, so shouldn't be anything too super earth-shattering. If you're in college algebra, you've probably seen this before. If not, it'll come shortly. But we're going to talk about the sum of cubes. So if I have two numbers, a cubed plus b cubed, okay, you got to have plus, hence the sum of cubes. That will always be able to be factored into a plus b times a squared minus ab plus b squared. So figure out what is getting cubed. So for instance, x squared plus 8, okay, a would be, or x cubed plus 8, sorry, x cubed, x is what's getting cubed, and 8 is 2 cubed, so your a would be x, your b would be 2. The difference of cubes works very similar. So you're going to have a cubed minus b cubed. So very similar setup. As long as something is cubed, it can always be factored. That's going to be a minus b times a squared plus ab minus, or plus b squared. So use those to help you out. It may be able to help you with some of the factoring that you will need to do today for your homework. So let's take a look at a couple examples here. We're going to add these fractions. Now, if you remember from about a minute ago, I said we need common denominators if we're going to add fractions. So hopefully you guys all recognize already that we do not have common denominators. So what we're going to do is we're actually going to factor our two fractions. So I'm going to have 2x minus 3 divided by, now 5x squared plus x minus 4 is going to factor into 5x minus 4 and x plus 1. And we're going to add that to 3x plus 5 all over 5x minus 4 and 2x plus 3. Now, what I like to do to find my common denominator, okay? 5x minus 4, excuse me, shows up in both fractions, so that's good. But what really changes is the second factor here, the x plus 1 and the 2x plus 3. That's why these two denominators ended up different. So to get a common denominator, especially with something like this, just multiply by, make sure every factor shows up in that denominator. So my actual denominator is going to be 5x minus 4, x plus 1, and 2x plus 3. So each of those different pieces shows up there. And I'm going to have another set of that over here. 5x minus 4, and x plus 1, and 2x plus 3. And I need to multiply each of these fractions by what piece they're missing. So if I look at the first fraction, 2x minus 3 over 5x minus 4 times x plus 1, okay, I can see right away that the 2x plus 3 shows up in my common denominator, but does not show up in this first fraction. So I'm going to multiply everything by 2x plus 3 and 2x plus 3. Now, denominator is good, and I just have to FOIL out that top piece. You can FOIL it, you can box it if you see something special in this case that'll help you multiply that. Do what you need to do, but foiling or boxing will always work here. And of course, by the power of working ahead, I know that that is 4x squared minus 9. And I repeat that same process. What am I missing from the second fraction that doesn't show up in my common denominator, or that shows up in my common denominator that is not there? Well, I see it's the x plus 1 piece. So x plus 1 and x plus 1. Again, FOIL out that top. You don't have to do anything with the bottom. Now you have every piece that you need. So I'm going to multiply all that out, FOIL it out. You're going to end up with 3x squared plus 8x plus 15. And now, since we have common denominators, we just add the top pieces. So I just need to collect my like terms. Looks like I've got 4x squared and a 3x squared that can go together, so I get 7x squared. I don't have any x's in the first fraction, but I have that plus 8x in the second fraction. And I've got minus 9 plus 15. So That should be a 5, not a 15. Just a regular 5. You guys probably caught that already, but negative 9 plus 5 is going to give me minus 4. And that stays over our common denominator. Okay, you guys do not need to multiply that back out. You could if you wanted to. It's just extra work that you don't need to do. So I'm going to go 5x minus 4 times x plus 1 times 2x plus 3. And that is how you're going to do those. The key to these, really, everything you want to look for right away is going to be trying to factor and see what factors you have and what factors you don't. So, looking at another example here, this first. Right away, I see I'm working with a division problem. So, right away, what I want to do, I'm going to factor right away. You guys can do this without factoring right away, but I like to make things as easy on myself as possible. So this top one here, a cubed, or this first fraction, a cubed plus 2a squared minus 4a minus 8. Okay, we need to factor this. And since I have 4 pieces, I'm going to do what's called factoring by grouping. So college algebra people, I know you've already talked about this a little bit. So to factor this, what I'm going to do is I'm going to take a cubed plus 2a squared minus 4a minus 8. Okay, and if you're not in college algebra, that's fine. We talked about this last year in Algebra 2, so hopefully you guys have a little bit, kind of comes back to you right away. So I draw my line down the middle, and I ask myself, what can I take out of this left side? So the a cubed plus 2a squared. I see the common factor there is going to be a squared. And what's left when I factor out that a squared is going to be a plus 2. And now in order for this to work, I need my sets of parentheses to match exactly. So I am going to take out a negative 4 on the right. So I have a plus 2 in my parentheses. So this actually is going to factor into a squared minus 4 and a plus 2. Now, we got a very special case here. Maybe you guys recognize it, maybe you don't, but a squared minus 4 can actually be factored into a plus 2, a minus 2 by the magic of difference of squares, and I've got that a plus 2 written there. Now, for the most part, everything's going to factor out the same way that things have always factored for us, so that's okay. Now that we're dividing, we're going to do our keep, change, flip. So I'm going to write my problem as, and since I have a plus 2 and a plus 2 twice, I'm going to go a plus 2 squared times a minus 2 all over. Now, I look at 2a plus 1. I have no common factors. I can't factor this at all, so that is actually just going to stay the way it is. So we keep the first fraction. We're going to change division to multiplication, and we're going to flip the second fraction. When we flip this, let's make sure we get this factored correctly. 2a squared minus 5a minus 3 is going to break down into 2a plus 1 and a minus 3. Okay, 4a squared minus 8a, just so that we're all on the same page here. This is not a difference of squares. 4a squared is a perfect square, however 8a is not. So the only thing I can take out is a common factor. So I can pull out a 4a from both of those, and I'm going to be left with a minus 2. So now that I've got this factored out, I am going to flip. So I'm going to have 2a plus 1 times a minus 3 all over 4a times a minus 2. Now we can multiply all of these together. What I really like to do from here is I'm going to look to see if I can actually cross-cancel anything. So I see an a minus 2 and an a minus 2 here, and I'm also left with the entire 2a minus 1. I can treat this as an entire factor. That's the whole denominator. Cancels with that factor there, cross-canceling. You can also cancel within your fractions. That's fine. And now really all we have is what's left. You just multiply across the top, multiply across the bottom, so you're going to have a plus 2 squared times a minus 3 all over 4a. That's going to be your final answer. You do not need to multiply that out if you do not want to. If you want to, that's fine, but this is all I'm really going to look for on that one. So there's your homework. Give these a shot. If you guys have questions, let me know. Shoot me an email. I might be around school if you can catch me there. Otherwise, stop in sometime and we'll get you squared around. Remember, the big thing here, factor everything as much as you can, and that will help you a lot. So find those factors, look to cancel, and make the problem a little simpler for you. Again, if you have any questions, let me know. Thanks for watching.